My name is Nathanial Wolff. I'm a nuclear engineer, and the TVA, or Tennessee Valley Association, they've asked us to help reduce the heat gain on one of their Sequoia nuclear plants. The scale model, the first one we came up with was the slather approach, as we called it, where we took a can and we just started smearing it in concrete. The problem is that it doesn't work very well. It's not uniform at all. The shape is not distributed evenly throughout the space, and it's not smooth. It's completely unusable. Our lead researcher, Tony, he came up with our 3D model approach, which was more defined in scale and size of what we wanted to accomplish. But the only problem was that we couldn't really get the concrete to adhere to it. So it was more of a mold. Thankfully, with Gretchen, she came up with the mold approach, which is what this fantastic piece of masonry is here, where we fill the concrete into a bucket and we'd be able to pull out the mold from there. It's actually 76,000th scale of the actual containment building. And so what we did is that we took the first approach of the paint and we did the experiments, clicking on the temperature around it, and then we did the tarp, and then we did both. The heat lamps were positioned on the front and the back. Because of the scale size that we had chosen, you could actually fit both lamps on both sides and still have the control and the experimental at the same time without fear of overlap. What's great about that is that it really limited the differences between models that we could have built because it's the same model with the same surface. So that was really excellent for our experimental design. And so the second semester was when we started doing all of the experimental procedures and the reports and the data collection. And what we found is that the paint, by a pretty significant margin, is the best, reducing the heat gain by about 40%, whereas the tarp was about 13%, and the combined approach was about 37%, which sounds a little counterintuitive because that's less than the paint, but we assume that's because of the air gap layer might have prevent creating a sort of convection heating on it. And so we decided to recommend to TVA that they go 100% on the thermoseal. Post-college, I think that this senior design project will do a lot for me with the part that we don't get to spend a lot of the time in the classroom with, which is project planning and project scheduling and meeting and communication skills. We just spend a lot of the time in the nuclear department going over the hard science of everything. But the senior design project really helped pull out the softer skills, communication with my team, scheduling with my team, meaning I love my team. My team's great. We've been doing a fantastic job all year. And I think that this design really helped us cultivate those skills.